Here I have a video that explains how to do some of the problems on the rationals review. When I was walking around, I saw that that was probably the biggest challenge to some of you, so I figured I would make a video even though there already is an answer key. All right. Here you can just see the answers to problems 1 and 4. Those are the two I chose to do a video for. All right. But if you want to hear an explanation, here we go. Number 1 is an expression that you're asked to simplify, and it involves complex fractions. Complex fractions is a complex way of saying little fractions. Okay, when you have little fractions in a problem like this, you want to multiply the top and bottom by the least common multiple of the small denominators, which is a mouthful. But pretty much, you've just got to choose to multiply by an expression that all little denominators go into. Okay, x squared and x are the two little denominators. They both go into x squared. So that's the best idea to choose, to multiply the top and bottom by x squared. You multiply all 4 terms by x squared. So the 1 over x squared, when you multiply that by x squared, you just get 1. All right, that's what I have over here. When you multiply the x by x squared, you get x cubed. So the top becomes 1 plus x cubed. All right, we get rid of the little fractions. That's how you'll always know if you've chosen the right green, the right expression to multiply top and bottom by. If your next step still has little fractions, then you messed up. You got to go back and choose something more appropriate. The bottom, x times x squared is x cubed, and 1 over x times x squared, well, is just x. So we're left with 1 plus x cubed on the top, and then x cubed minus x on the bottom. And then once you have the little fractions all gone, you just factor. The denominator is probably a little bit easier to factor. You can factor out an x, right? X is a GCF for the bottom, and you're left with x squared minus 1. Now, I didn't show that, but x squared minus 1 is a difference of 2 squares. So when you factor out the x, you're left with x plus 1, x minus 1, right? The top is a sum of cubes. Now, that's something you should have learned in Algebra 2. There's a formula for a sum of cubes. The x cubed gives it away, and then 1, well, 1 is a perfect everything, right? 1 is a perfect cube for short. So there's a formula to follow, and we end up with 1 plus x times the trinomial 1 minus x plus x squared. Right? If it's a sum of cubes, the order of the operations, the order of the symbols is plus minus plus. 1 plus x, 1 minus x plus x squared. Then 1 plus x and x plus 1 are, yes, they do mean the same thing. Addition is commutative, which means when you switch the terms around, you do end up with the same expression. Subtraction is not commutative, right? So you got to be careful. If it was 1 minus x and x minus 1, you'd have to just remember that when you cross those out, you got to throw a negative in front of the entire problem. All right, but when we cross off the 1 plus x and the x plus 1, they just disappear, and we're left with the answer. Okay? So that's the answer over there. Can't do anything else. That was problem 1. Problem 4 is a subtraction problem. Okay, subtraction and addition, ironically, is more challenging than multiplication and division, I think. Okay, because we need to have a common denominator. When you're adding and subtracting, you do need a common denominator, so you have to create. Number 4, by the way, I factored the bottom left. That's not how the problem was written, right? It was written as the trinomial x squared minus x minus 20, but I factored it. You have to do that so you know what to multiply the other fraction by. We need an x plus 4 over x plus 4 because that's the factor missing from the second fraction that is in the first denominator. Okay, you understand that? We have to multiply the second fraction by x plus 4 over x plus 4 to create a common denominator. All right? So I went down here from there, I believe. Yes. So all I've done now in the second step, as you can see, is I distributed the x. We've got to multiply the x by the x plus 4 before we deal with the subtraction, right? Multiply first. So we end up with x squared plus 4x. Okay? Now, because we have a common denominator of x minus 5x plus 4, we can now subtract the second numerator from the first numerator. All right? So we subtract the quantity x squared plus 4x like this. You don't need to show this step. I just wanted to clearly show you that you've got to rope off the x squared plus 4x. The subtraction symbol gets distributed, right? You're subtracting not just x squared, but also you're subtracting the whole quantity. So you have to consider the top of the second fraction sort of as parenthesized. Okay? So we have to distribute the negative, and we end up with this guy, right? 2x squared minus 5 minus x squared minus 4x over that same denominator. Okay? And then we just collect like terms on the top, and we end up with x squared minus 4x minus 5, right? I went just straight down from there. And then we'd be finished, but we can still factor further. It's a very long problem. They can't get much longer than this, but it's kind of nice when it works out, right? X minus 5x plus 1 is how the numerator factors, and the x minus 5's cancel, and we're left with x plus 1 over x plus 4. Of course, we cannot cross off the x's, right? When you have addition or subtraction, the terms, it's as if the terms are in parentheses, okay? So if it was just 1x over 4x, yes, we could cross off the x's. That's multiplication. With addition, you can't do anything. All right, so we get x plus 1 over x plus 4, and that's that. Okay? I hope this was helpful.